So for my Calculus 1 class, we're at the point where we're talking about integration, right? So I like to use this little problem to illustrate some things. Integral of log x. So how do you find the integral of log x? If you look it up in the book, it's not there. Of course you can look it up online. Well, there's some ways to do this, but the way that I want to focus on is that, what do we know at this point in Calculus 1 about integration, right? What is this? What's a derivative? Yeah? So we took the derivative of something, and we got log x. That's what this means, okay? This is, the antiderivative. So this is what we're looking for, right? So without knowing a whole bunch of techniques, is there a way we could get this? Well, think about it, right? We know that when we take a derivative, when we have this onion structure, right, that it's derivative, copy, derivative, copy, derivative, copy, and we're always working towards the core function, yeah? So if I make this thing the core of an onion, and I put something up here like an exponent, right, because this thing has an exponent of 1, yeah? So maybe this will get me where I want to go. Let's try this. So what do? We do the derivative of the outside first, right? So the 2 comes in front. Our new exponent is going to be 1. Copy. Our next step is derivative. But the derivative of log x is a line, right? Copy, derivative, 1 over x. So the 2 would have been easy to get rid of, right? If I put a constant in here, a 1/2, yeah, that would have gotten rid of the 2, okay? If I could somehow make an x come out of this thing, I could multiply x times 1 over x, that would make it a 1, and I would get log x. But in order to get an x in here, I'm going to have to use product rule. So this isn't looking very positive. Maybe we could use product rule, yeah? Because product rule has those copy steps in it, right? So what would we try? One of our things in the product is going to have to be log x. The other thing would be something like x. Let's try and take this derivative just to see what we get, yeah? So it's product rule. Right? The first thing goes in the first block. The second thing goes in the second parenthesis. That's nice. That's our derivative, right? That's what we want, okay? The derivative of x, that's nice because it's 1, okay? So 1 times log x, it's log x. So we're doing good here. And the derivative of log x, again, is 1 over x. Now, 1 over x times x, this is 1. Plus, log x times 1 is log x. So that's pretty good. The derivative of this is 1 plus log x. If I could get a minus 1 over here, I'd actually be done, right? What do I have to put in here to get a minus 1 in the derivative? I think that's not too bad, right? It's just minus x, isn't it? The derivative of x log x is this product. X log x is going to be 1 plus log x. And then I have minus x. The derivative of minus x is minus 1. 1 minus 1. So that's going to be log x, right? So this, apparently, is going to be x log x minus x. Since it's an antiderivative, there's the possibility of a constant out here. So all we needed to do this derivative was, this integral, was to understand that this is a derivative, okay? And then we can try some stuff. We can take the derivative and we can see what we get. And as long as we know how to take a derivative, we can modify this and see if we can't get where we're trying to get. So sometimes you can solve some pretty nasty integrals like this. It's a technique that I wanted to introduce. If you have any questions about any of this stuff, send me an email.